Hello students, welcome back to the class. So in this class, let us learn about the distinguishing tests for amines, under which there are two tests which we need to discuss. One is Hinsberg test and the second one is nitrous acid test. So now before going to the distinguishing test, let us just recall what are amines. So you know amines are the derivatives of ammonia in which one or more of the hydrogen atom have been replaced by alkyl or aryl groups. So depending on that, you have primary amine, secondary amine and tertiary amine, where primary amine has only one alkyl or aryl group, secondary amine has two alkyl or aryl group, and tertiary amine has three alkyl or aryl group present in it. Where this R group, if it is alkyl group, it is called alkyl amine or aliphatic amine. If an aromatic group is present, then it is called aryl amine. So I hope you remember this. Now let us know how to distinguish these different classes of amines. So which are those classes? Primary, secondary and tertiary amines, isn't it? So there are so many qualitative tests available to identify the presence of an amino group, including the solubility test, litmus test and other chemical reactions test, out of which now we are going to study these two tests, that is Hinsberg test and the nitrous acid test. So let me begin with the Hinsberg test. What is this Hinsberg test? It is a test for the detection of primary, secondary and tertiary amines. This reaction was first described by an Oscar Henrik Daniel Hinsberg, on behalf of which this test is also called as Hinsberg test. And the reagent what we use in this test is Hinsberg reagent. And what is Hinsberg reagent? It is benzene sulfonyl chloride. So this is the structure of benzene sulfonyl chloride. Okay, this benzene sulfonyl chloride is the Hinsberg reagent which is used in Hinsberg test, and the test which is used for the detection of primary, secondary and tertiary amines. Let us see how this primary amines react with the Hinsberg reagent, that is benzene sulfonyl chloride. So here you have a primary amine which is having only one alkyl or aryl group attached to the nitrogen atom, right? So a primary amine, when it reacts with an Hinsberg reagent, it forms a precipitate, that is a salt is formed, that is N-alkyl benzene sulfonamide. So it is, what happens in this reaction is one of the hydrogen is replaced by the Cl of the benzene sulfonyl chloride, and that is removed as HCl. This H and the Cl is removed. Now what is remaining here is RNH, right? This RNH will be substituted for this chloride place, so that RNH. So that is why it is called N-alkyl benzene sulfonamide. Now because it has an amide group, it is called sulfonamide. And this salt is a precipitate. The precipitate formed is soluble in sodium hydroxide solution. And the salt is soluble because it contains an acidic hydrogen in it. Because of the presence of an acidic hydrogen in this salt, it is soluble in aqueous NaOH solution. So now let's just see again. Primary amine reacts with benzene sulfonyl chloride forming a sulfonamide. This sulfonamide salt is soluble in NaOH. So the salt or the precipitate which is formed, if it is soluble in NaOH, it means that the given amine is a primary amine. Now let us see how a secondary amine reacts with this Hinsberg reagent. So we have a secondary amine where it has two substituted groups linked to the nitrogen atom. reacts with the benzene sulfonyl chloride or Hinsberg reagent. As usual, because it has a replaceable hydrogen atom present here in this amine, so it is removed along with the chloride of this benzene sulfonide chloride and removed as HCl. Now what is remaining here is NR1R2, and that is substituted for this place, forming NN dialkyl, NN dialkyl benzene sulfonamide. Now, this precipitate formed is insoluble in aqueous NaOH. So previously you saw for primary amine, the salt what is formed is soluble in aqueous NaOH, whereas if the precipitate formed when an amine reacts with the benzene sulfonyl chloride is insoluble in NaOH, then it is a secondary amine. Moving on to the reaction between tertiary amines and Hinsberg reagent, tertiary amines do not show any reaction with the Hinsberg reagent. Why? Because tertiary amines do not contain any replaceable hydrogen on the nitrogen, and thus these tertiary amines cannot be deprotonated. See, if you see tertiary amine, it has all three alkyl or aryl group linked to the nitrogen. There is no replaceable hydrogen atom present, isn't it? Because of this, they do not react with the benzene sulfonyl chloride or the Hinsberg reagent, and we see no reaction. Okay. Now to sum up, the Hinsberg test that is used to distinguish between amines, where amines react with the Hinsberg reagent called benzene sulfonyl chloride, and primary amines form a precipitate which is soluble in aqueous NaOH, where secondary amine forms a precipitate which is not soluble in aqueous NaOH, and tertiary amines do not show any reaction. So this is how we can distinguish between different classes of amines. So if the given amine forms a precipitate which can be soluble in NaOH, then it is primary amine. If you have an unknown amine forms a precipitate, but if that precipitate is not soluble in aqueous NaOH, then it is a secondary amine. If no reaction, you have an amine, allow it to react with the benzene sulfonyl chloride, and if it doesn't show any reaction, it is a tertiary amine. Why tertiary amine do not react? This is because tertiary amine do not have a replaceable hydrogen atom. Okay, that is the reason tertiary amine shows no reaction with the Hinsberg reagent. So this is how we can distinguish different classes of amines using the Hinsberg test. Moving on to the second test which is used to distinguish amines, that is nitrous acid test. So the nitrous acid can also be used to differentiate between different classes of amines, and because nitrous acid is unstable, it is prepared by the reaction of dilute HCl or dilute sulfuric acid with sodium nitrite at room temperature. So it is sodium nitrate treated with the dilute HCl or H2SO4, which forms nitrous acid, and this nitrous acid can be used to differentiate different classes of amines. So let us see the reaction of primary amine with nitrous acid. When aliphatic primary amine reacts with this nitrous acid, there is an rapid evolution of nitrogen gas can be seen in a clear solution. See, the primary amine RNH2, which is a primary aliphatic amine, when it reacts with HNO2 or nitrous acid, it forms an alcohol, that is ROH. Along with that, nitrogen gas is evolved. Okay, so this indicates that it's a primary aliphatic amine. So why I'm telling primary aliphatic amine? This is unlike the Hinsberg test where both alkylamine and arylamine gives the same product or they react the similar way. Here the aliphatic primary amine and the aromatic primary amine, their reaction is different. That is why here I'm talking about only the aliphatic primary amine. So it forms a nitrogen gas that can be seen evolving. Whereas an aromatic primary amine, it reacts with the nitrous acid in presence of cold HCl and forms diazonium salt. So aromatic amine, say for example phenylamine or aniline, it reacts with HNO2 in presence of cold HCl, that is at 5 degrees Celsius, forming a diazonium salt. Here it is benzene diazonium chloride. Okay, and now this compound which is formed, that is the diazonium salt, if it is further heated at room temperature, then it undergoes decomposition, forming or releasing the nitrogen gas. Okay, this is how primary aliphatic amine and the primary aromatic amine, they show different reaction with the HNO2 or the nitrous acid. Coming to the secondary amine reaction with nitrous acid, secondary amines react with nitrous acid forming nitrosamine. The compound formed is nitrosamine. It is an yellow oil kind of compound. So that is how we can differentiate between primary amines and the secondary amines. So here R2NH with HNO2, it forms nitrosamine, which is an yellow oily compound. Here both aliphatic and arylamines, they form identical products. So only for the secondary amine reaction with nitrous acid, both alkylamine and arylamine, they form the identical product or they react in a similar way. And whereas in tertiary amines, again we have to look for tertiary aliphatic amines and tertiary arylamine. So let us see this tertiary aliphatic amine, how it reacts with nitrous acid. So when tertiary aliphatic amine reacts with the nitrous acid, it forms nitrite salt. Whereas tertiary aromatic amine react with nitrous acid, where it forms nitrosoaniline, which is an yellow precipitate. Okay, so this is how this secondary and tertiary amines can be distinguished. Tertiary aliphatic amine forms nitrite salt, which is soluble, whereas tertiary aromatic amine forms an yellow precipitate, which is nitrosoaniline. So now to sum up this reaction of amines with HNO2, aliphatic amines and aromatic amines, they react differently. Hence we have to look at both these alkylamine and arylamine reaction. Here the primary aliphatic amine, when it reacts with nitrous acid, it evolves, a rapid evolution of nitrogen gas can be seen with a clear solution because it forms an alcohol solution. Then secondary aliphatic amine, they form an insoluble yellow oil. So that is how you can distinguish between a primary aliphatic amine and the secondary aliphatic amine. Then tertiary aliphatic amine, it forms a clear solution because the salt which is formed is soluble, hence it forms a clear solution. Coming to the aromatic amines, primary aromatic amine, it forms diazonium salt, which is a precipitate which on further heating releases the nitrogen gas. So this is how you can distinguish primary aliphatic amine from primary aromatic amine. Whereas primary aliphatic amine gives a rapid evolution of nitrogen, primary aromatic amine forms a salt which on further heating only releases the nitrogen gas, that confirms it is a primary aromatic amine. Then similarly, secondary aromatic amine, it forms an insoluble yellow oil just like the secondary aliphatic amine, which means secondary aliphatic and secondary aromatic amine, they show a similar reaction or identical reaction in the products. And tertiary aromatic amine forms an yellow precipitate, whereas tertiary aliphatic amine forms a soluble nitrite salt forming a clear solution, whereas aromatic amine, tertiary aromatic amine forms a precipitate in the solution. So this is how amines can be distinguished using HNO2 or the nitrous acid test. Now you know that amines can be distinguished, different classes of amines can be distinguished qualitatively by using Hinsberg test and nitrous acid test, where different classes of amines gives different products with these above reagents, that is nitrous acid and the Hinsberg reagent, benzene sulfonyl chloride, based on what? Based on the number of substituents present on the nitrogen. Thereby we can distinguish different classes of amines using these two tests.